The major criticisms of Karl Popper's falsifiability criterion show that the debate over demarcating science from non-science is more complex than a simple rule of testability. It begins with Thomas Kuhn's objection that Popper's model describes only moments of scientific revolution, not the everyday work of normal science, and that Popper's criterion cannot be generalized to the whole scientific enterprise. Kuhn's view is contrasted with Popper's insistence that replacing a rational criterion with a sociological one would be a serious error. Feyerabend goes even further, rejecting the possibility or desirability of a strict boundary between science and non-science, and arguing that science advances by using many methods rather than one fixed procedure. Lakatos criticizes Popper for separating the game of falsifiability from the real goal of science, namely the development of true or increasingly truth-like theories. Other critics argue that Popper's criterion sometimes excludes legitimate sciences while also allowing some pseudo-scientific claims to appear scientific merely because they make false but testable assertions. Bartley and Champion emphasize that Popper's philosophy refuses to provide positively justified foundations of belief, which creates a large gap between his approach and much of traditional philosophy. Putnam argues that Newtonian mechanics was not accepted mainly because of risky, falsifiable predictions, but because it successfully explained phenomena already known. Hacking similarly observes that many real scientific practices, especially experimental ones, cannot be understood simply as attempts to falsify or corroborate theories. Sokal and Brickmont object that falsifiability does not accurately describe how science works and cannot clearly separate astronomy from astrology. Also, mathematics is not experimentally falsifiable in Popper's sense, while some forms of economics, such as Austrian macroeconomics, have been described as empirically unfalsifiable. A central difficulty is the Duhem-Quine thesis, according to which experiments do not test isolated hypotheses but whole networks of assumptions. For this reason, an apparent failure of Newton's first law may not falsify the law itself, because auxiliary assumptions or additional hypotheses may be responsible for the failure. Stove criticizes Popper's classification of scientific statements and argues that it wrongly excludes statements that Popper himself treats as basic to observation. O'Hear and Salmon add that Popper's epistemology tends toward skepticism and cannot completely avoid inductive procedures, especially when it speaks of corroboration. A further problem concerns verisimilitude, because Popper wanted to compare false theories as better or worse approximations to truth, but critics such as Miller and Tichy showed serious defects in his formal definitions. Popper acknowledged the difficulty, but argued that the idea of verisimilitude still has heuristic and intuitive value even without a fully satisfactory formal definition. We can extend or revise falsifiability, especially Lakatos's sophisticated methodological falsification, which evaluates whole research programs rather than isolated hypotheses. In Lakatos's view, a program is scientific when it is progressive, producing new confirmed predictions, and degenerative or pseudo-scientific when it ceases to predict anything genuinely new. Thagard, Rothbart, Reich, and Merton offer alternative criteria, focusing on progress, testable implications, integration with established sciences, and the institutional values of scientific practice. In conclusion, falsifiability remains important but insufficient by itself, because not all falsifications are alike, and the demarcation between science and pseudoscience requires a more nuanced account of method, progress, evidence, and scientific community.